Okay, so this is going to be the continuation of the central limit theorem, right? So we saw that x bar is normally distributed with a mean mu, a population mean of mu, and a population standard error or population or standard error of sigma over square root of n, right? So this is what we said. So when can we use the central limit theorem, right? So n is our sample size, right? How many people or objects we're going to obtain, right? And this is when we can use it. We can only use it when the data is normal, right? N can be anything because as we saw in the simulation in the previous video, right? Whether the data, the initial population was normal, right? It didn't really matter what n was, right? Because even with n equals 5, we still got a normal distribution. So that's fine. N can be whatever we want. It can be low, but as long as we know that the initial data is normal, then we're good. We can use central limit theorem. Now, let's say the data is not normal, so it's skewed. Well, as long as n is greater than 25, this is our threshold. As long as it's greater than 25, we can use the central limit theorem. Okay. Other books use n is greater than 30, but we're going to use n greater than 25 in this class. Okay. Now, when can't we use it? We can't use it when the data is not normal and n is less than or equal to 25, okay? So if this assumption happens, then go ahead, and then we cannot use central limit theorem, and we say we cannot do the problem, okay? So at this point, you can pause the video to write this down, and I'm gonna go ahead and go on the PowerPoint, okay? So hopefully you pause the video or whatever you got to do, right? So now we're going to go to the PowerPoint and I'm going to ask you these questions. These questions are going to be very, very similar to the ones that you're going to find in your quiz. Okay. So maybe put a big fat star there. Okay. So let me see if I can get it. Yes, I can. Okay. So maybe put a big star here that this is what maybe may be in the quiz. Okay. So can we use the central limit theorem for means for these scenarios? Okay. So now that you hopefully copied it down, right? Copied down what I had on the paper, you can go ahead and answer these questions. Okay. So IQs are normally distributed. We get 40 people and find the mean of the IQs. Okay. Well, IQs are normally distributed. So that tells us from the very beginning that we have a normal distribution, right? So we already know the data itself is normal. So we get 40 people. Well, the data is normal, so it doesn't really matter what n is, right? We can use it. So this one, yes, we could use it. We can use central limit theorem, okay? All right, now this one. We measure the heights of 48 football players, okay? So we have a large n, right? And calculate the mean of those heights. Now, notice we don't know what the initial data is. It doesn't tell us that it's normal or it's skewed or anything, but we know, even though we don't know what the data is, right? We do know that n is greater than 25. 48 clearly is greater than 40. 48 is greater than 25. I cannot talk. So in this case, yes, you can still use it. We don't know what the distribution is initially, but the central limit theorem tells us that if n is greater than 25 and 48 is, then we can go ahead and use it. Okay. So the third one, the scores of a physics test, that shouldn't be an A there, was skewed right. Okay, so the beginning, we know initially that the data itself is not normal because it's skewed right. So when it's skewed right, what do we get? We got 20 scores and averaged them out. So we took 20 random scores and we found the mean of them. Is this normal? Is this normal? No, clearly not. It's not normal because it told us it was skewed right? But can we use the central limit theorem? Well, in this case, no, we can't use it, right? Because first of all, this is not normal, right? And 20 is definitely not greater than 25. So can we use it? No. Okay, we cannot use the central limit theorem. Okay. Now, what about part D? The scores of physics tests was skewed right. So same problem, but now we get 40 scores. Well, even though this is not normal, right? Even though this is not correct, the n is greater than 25. So yes. Now we can use it because even though the data is not normal, n is greater than 25. Okay. Okay. IQs are normally distributed. Okay. So we already know that they're normally distributed, but n is not quite greater than 25. Well, remember what it said in the first one? Data is normal. N can be whatever we want, right? So even though n is really, really, really small, we know that from the very beginning, the data itself is normal. So do we need to go ahead and say that we can't do it, or can we use it? Well, we could use it because it doesn't really matter what n is. we already know that the data is normal. So this is also a yes. Okay, so hopefully this made sense, right? So, and if you have a question, please feel free to ask me, right? But this was just basically what we were basically doing. So let me go ahead and exit here. I'll stop the video here so that it won't get too long. And then in the next video, I'll go ahead and do a physical problem of when it satisfies the assumptions, and we can go ahead and do the problem. Okay.